Then, dear students, we're moving on to the problems based on the moment distribution method, analysis of beams. Analyze the continuous beam using moment distribution method. As I said in the previous lecture, the first step is the fixed end moments. The calculation of fixed end moment, then consider M bar AB, since it is an central point load, that means M bar AB is minus WL by 8, M bar BA is plus WL by 8. Then in the case of BC, since it is subjected to an eccentric point load, M bar BC is minus W AB square by L square and M bar CB is W A square B by L square. After that, find out the distribution factor. In this case, the joint B is connected by two members BA and BC. In the case of BA, far end is A. The far end is simply supported, that means the lattice stiffness is 3 by 4th of I by L. In the case of BC also, far end is simply supported. In that case also, lattice stiffness is 3 by 4th of I by L. Then find out the total lattice stiffness and the distribution factor will be obtained as I by 4. Lattice stiffness divided by total lattice stiffness. That means I by 4 divided by 7 by 16I. That is 4 by 7. Then lattice stiffness divided by total lattice stiffness in the case of BC is 3 by 7. After getting this fixed end moment and the distribution factor, all these values should be entered in the moment distribution table. So fixed end moment and distribution factor. Then check the end supports. Here the end supports are supports A and C. In the case of A, since the support is a simply supported one, that means the moment at that joint should be is equal to 0. Here the value is minus 75. We have to make the moment at that particular joint is equal to 0. So we have to apply plus 75 here. When we apply plus 75 here, the half of the moment should be carried over to the far end since this end is a fixed one. The next end support is support C. C is also simply supported 1. That means we have to make the moment at here is equal to 0. But there is some moments the value is 50. We have to make the moment at here also is equal to 0. In order to make this 15 is equal to 0, we have to apply minus 15. When we apply minus 15 here, the half of the moment should go to the far end. Then after this carryover step, please find out the sum. Here is 0, here is also it is 0. Then here it is 112.5 and here it is minus 52.5. We know what will be MBA plus MBC should be is equal to 0. But here it is 112.5 minus 52.5, that is 60. Here the total moment is not is equal to 0, the value is 60. In order to make the total moment is equal to 0, we have to apply minus 60 here. That means we have to substitute 4 by 7th of minus 60 here and 3 by 7th of minus 60 here. When we apply some moments like this, if the far end is fixed, there should be some carryover. But in both the cases, the far end is not fixed, both are simply supported. So that means there should not be any carryover. Then find the sum. This is 0, 78.21 minus 78.21 and this is equal to 0. Then check the support conditions. Support A is a simply supported 1, that is 0. Support C is also a simply supported 1, the moment is equal to 0. The joint B, the total moment should be is equal to 0. The total moment is equal to 0. After getting this step, we can stop the iteration. Then we can draw the bending moment diagram. Consider the clockwise moments are positive and all the negative moments are anti-clockwise direction. Draw the free bending moment diagram and draw the fixed bending moment diagram. Then combine these two. Then find out the reactions by considering each span as a simply supported one. Then mark all the reactions, mark all the external loads and mark the moments obtained here. The negative values will be marked as the anti-clockwise direction and the positive values will be marked in the clockwise direction. Then mark all the moments, then apply the equations of equilibrium, find out all the reactions, then draw the shear force diagram. Then moving on to the next problem, a continuous beam ABC fixed at A and C, simply supported at B, consists of spans AB and BC of length 4 meter and 6 meter respectively. The span AB carries a UDL of 20 kN per meter, while the span BC carries a UDL of 12 kN per meter. Analyze the B. Then find out the fixed end moment. Then find out the distribution factor. Since the far end is, when we are considering joint B, far end A is the fixed one and C is the fixed one. That means the latest difference is I by L. Latest difference is I by L in both the cases. Then find out the distribution factor and find out the fixed end moments. Enter all these values in the moment distribution table. Then check the end supports A and C. Since it's a fixed one, that means there should be some moments. No need to any end correction. Then after that, moving on to the intermediate support. In the case of intermediate support, the total moment is not is equal to 0. The total moment is 26.67 minus 36, that is minus 9.33. So we have to make that moment is equal to 0. That means we have to add plus 9.33. How we will add? 3 by 5th of plus 9.33 will be here and 2 by 5th of 9.33 will be here. Then after substituting this, then check the far end is fixed or not. If the far end is fixed, then there should be some carryover moment to that far end in the same sense. That means if it is plus, this should also be plus. After this carryover steps, then find out the total moments. Then check the support condition. Finally, the support A is the fixed one. There should be some moment. Here there is some moment. The support C is also a fixed one. There should be some moment. Here is also a moment. The total moment at B should be equal to 0. The total moment at B is equal to 0. Okay, that means support conditions are satisfied. So we can stop with this iteration. So after that we have to draw the bending moment diagram as well as shear force diagram. Then in this case, a continuous beam ABC fixed at the end is loaded. Find the reactions and the support moments, draw SFD and BMD. Then considering this one, the joint B is connected by two members BA and BC. So find out the distribution factor and by substituting the equations we will get the fixed end moments. Then enter into the moment distribution table. In this case both the ends are fixed one, that means there should not be any end corrections. Then move to the intermediate support. Then in this case the total moment is minus 40, that means not to make the moment is equal to 0 we have to apply plus 40. 2 by 5th of plus 40 here, 3 by 5th of plus 40 here. Since the far end is fixed, there should be some carryover on to both A and C. Then after that find out the sum. Then here analyze the given continuous beam. In this case, there is some overhanging portion. Before moving on to the overhanging portion, as I said, the step 1 is fixed end moment. Find out the value of M bar AB and M bar BA, M bar BC and M bar CB. Then in this case, joint B is connected by two members BA as well as BC. So, find out the fixed end moment and the distribution factor without considering this overhanging portion. After getting the fixed end moments and the distribution factor, enter all these values into the moment distribution table. If there is any overhanging portion, in the first step in the moment distribution table will be the overhanging moment. In this case, the overhanging moment is 50 into 2, that means 100 kilonewton meter, that is coming in the clockwise direction. We have to mark the support moment MCD as minus 100. This 50 into 2, the clockwise direction, that means plus 100 will be the overhanging moment. The support has to resist that overhanging moment by substituting minus 100 as MCD. So substitute minus 100 here. After considering this overhanging portion and overhanging moment, then consider the joint C as a simply supported one. So the end support C is a simply supported one. That means we have to make the moment that there will be equal to 0. But at the first step itself, it is having some minus 100 here. In order to make that is equal to 0, we have to apply plus 100 here. and there should be some carryover 50. This should be the first step if there is any overhanging portion. After considering the overhanging portion, then write the fixed end moments here. Then consider the fixed end moments. In that case also, since the joint C is a simply supported one, there should not be any moment. But here 71.11. Make that moment also is equal to 0 by substituting minus 71.11 here. When we apply minus 71.11 here, there should be some carryover. That means if there is any overhanging portion, at that support we have to do two end correction. One is due to the overhanging moment and one is due to the support moments, fixed end moment. So after getting that step, after completing that step, then find out the sum. Then we will get minus 53.33, 53.33 minus 21.12, 100 and minus 100. Means end support conditions are satisfied. Then moving on to the intermediate support. And the intermediate support, the 53.33 minus 21.12, that is 32.21. In order to make the total moment at that joint is equal to 0, we have to apply minus 32.21. That means 2/3 of minus 32.21 will be here and 1/3 will be here. Then after, if you are applying like this, then if the far end is fixed one, there should be some carryover. But in this case, the support C, we are considering it as a simply supported one after considering the overhanging moment. So after this, find out the sum. Then after getting that, we can draw the SFD and BMD. Then analyze the given continuous B. We are considering A, B, C and D. At the first step, we have to find out the fixed end moment. M bar AB and M bar BA, M bar BC and M bar CB, M bar CD and M bar DC. After that, find out the distribution factor. In this case, the joint B and joint C are connected by two members. In the case of joint B, is connected by BA and BC. In both the cases, the far end is simply fixed one. That means the lattice difference is I by L. In the case of joint C, CB and CD, in both the cases, the far end is fixed one. That means I by L. Then find out the distribution factor. The sum of the distribution factor at the joint B is 1. As the sum of the distribution factor at the joint C is also is equal to 1. After getting the distribution factor and the fixed end moments, all these values should be entered in the moment distribution table. Check the end supports. In the supports, support A and D are the fixed one. That means there should be some moment. There's no need for any end correction. Then, since we are moving to the intermediate supports, when we consider intermediate support, the first is joint B. In the case of joint B, the total moment is 1.78 minus 6.67, that is minus 4.89. So, in order to make the moment at here is equal to 0, we have to apply 4.89 here. How we will apply? The half of the 4.89 will be here and half of 4.89 will be here. If you are applying a moment like this, the half of the moment, the carryover moment should go to the far end if the far end is the fixed one. Then half of the moment should go to A as well as C. Then moving on to the next intermediate support, joint C. The sum of the moment will be 6.67 minus 2. That means 4.67. 2/3 of, that means you have to apply minus 4.67 there. That means 2/3 of minus 4.67 will be here and 1/3 of minus 4.67 will be here. When we apply a moment like this, half of the moment should go to the far end joint D as well as joint B. After the carryover on both the joints, we have to calculate the sum of the moments. Then consider the intermediate supports. The total moment is equal to 0 or not. Here it's not is equal to 0. So we have to make the total moment at here is equal to 0 based on the distribution factor. When we apply some moment like this here, there should be some carryover if the far end is fixed one. This iteration process continues till the support conditions are satisfied. In this case, MBA plus MBC is equal to 0, MCB plus MCD is equal to 0. Then after getting the moments, we can draw the SFD and BMD. Then in this problem, analyze the given beam. Then we have to find out the fixed end moment as well as the distribution factor. After that, we have to enter the values in the moment distribution table. When we consider the support moments, end supports, the support A and support D are the simply supported one. So we have to consider the end supports first. That means we have to do the end corrections at the end supports first. Here, and A is a simply supported one. That means we have to make the moment at A is equal to 0. In order to make the moment at A is equal to 0, we have to apply 8 here. If we are applying 8 here, there should be some carryover at this here. Here also end support is 4. That means you have to apply minus 4. That means minus 2 is here. After this carryover, we have to find out the sum. After finding out this sum only, we will move on to the intermediate support. When we move on to the intermediate support, the total moment must be equal to 0, but here it is not is equal to 0. We have to make it is equal to 0 by on the basis of distribution factor of the negative of that particular moment. Then when we apply sum of the moment like this, 20 minus 8 is 12. That means 1/3 of, that means in order to make it 0, you have to apply minus 12. 1/3 of minus 12 is here, 2/3 of minus 12 is here. When we apply these two moments here, since the far end is not fixed one, there should not be any carryover. But here the far end is fixed one. That means there should be some carryover here. Here also, when we apply the moment at here, 8 minus 6, that is 2. That means we have to apply minus 2. 4 by 7 of minus 2 here, 3 by 7 of minus 2 here. Since the far end is simply supported one, there should not be any carryover, but here the far end is fixed one, there should be some carryover. After the carryover on both the sides, we have to find out the sum. Check the end supports, check the support conditions are satisfied or not. If it is not satisfied, we have to go the next iteration. Then this iteration will stop only when the support conditions are satisfied. After that, we have to draw the SFD and BMD. Then, in the case of analysis of the continuous beam with sinking of support, in this case, if there is any support settlement, there will be an additional fixed end moments due to that sinking of the support. For any span of length L, if delta is the difference of the level of the end supports that at each end, there should be some additional fixed end moment. That value is 6CA delta by L square. The nature of that fixed end moment is clockwise at each end when the right support is at high level. The nature of the fixed end moment is in the anti-clockwise direction at each end if the left support is at the high level. If there is any support settlement, we have to consider some additional fixed end moment of value 6CA delta by L square. That is plus 6CA delta by L square if right support is at the higher level, and the value is minus 6CA delta by L square if the left support is at a higher level. For example, determine the support moments and draw the SFD and BMD for the continuous girders shown in figure. If the support B sinks by 2.5 mm, the support B sinks. When you consider M bar AB, the support B sinks means left support is at the higher level. So, in the case of M bar AB, minus WL square by 12 minus 6CA delta by L square. In the case of M bar BA also, it is minus 6CA delta by L square, since in the case of AB, left support is at the higher level. When we consider BC, in that case, since the support B sinks by an amount, that means right support is at higher level. That means plus 6CA delta by L square. So, in the case minus WL by 8 and plus WL by 8, we have to consider plus 6CA delta by L square also. In the case of CD, there is no support settlement. So, the value is minus WL square by 12 and plus WL square by 2. After getting the fixed end moment and distribution factor, we can enter all these values into the moment distribution table, and then we can do the moment distribution. And after that, we have to draw the SFD and BMD. Thank you.